Now let us define the inverse of a function by means of algebra. So I will begin this by presenting the original function. So we're given this table. Okay, this is our original function table, and those are the tabular predictions for our descents given our time from 0 to 8, or from time, but the included time there is from 1 to 8. I'm going to tell you why it's still from 0 to 8. Now this is the graph. And going by algebra, we can actually get the linear function in terms of algebra for our f of t, which is equal to d. So we have 2 points there. Let's get 2 points, okay? And I want to particularly get 1 and 0.2 and 2 and 0.5, or 3 and 1.0 to be an easier way of computing the values. So first we have to get the slope. How do we get the slope? Our slope is equal to y2 minus y1. It's the formula for slope of a certain line, so x2 minus x1. So the slope would be 1.0 minus 0.2 all over 3 minus 1. We have a value which is 0.8 over 2, and that slope is just equal to 0.4. Now choosing 1 point, let's say 3 and 1.0, because I want my work to be a lot easier. Okay, so what is the standard equation of a line? We have y is equal to mx plus b. I mean, that's the general form of our equation. So y is equal to mx plus b. So using that form, we have our slope, which is 0.4 x plus b. How do we get b here? We have to replace 3 and 1.0 to our x and y variables here. So our y is 1.0 when our x is equal to 3. So that's 0.4 times 3 plus b. So we have b is equal to, transposing this side, we have 1.0 minus, this is 1.2 in this case. So our b is equal to, what is our b? It would be equal to negative 0.2. Now we can express our equation. So our equation would be, finally, okay, we have y is equal to f of x, or f of t, which is just f, okay, and that's equal to what is this one? We have, let's say this is our x. Let's put it in term x, not to be confused with this one, okay? So we have 0.4 x minus 0.2, and our slope is 0.4, and our x-intercept is, how do you compute the x-intercept? Let y is equal to 0. So if we let y is equal to 0 to solve for x-intercept, why do we need the x-intercept? Because as you can see here, you could see this portion here, that's the x-intercept. So it is relative or relevant to our computation of the function, the linear function, original function. Okay? So to compute for our x-intercept, let y is equal to 0. So if our y is equal to 0, 0 then would be equal to 0.4x minus 0.2. And 0.2 by means of transposition, we have 0.4x. And our x would be 0.2 over 0.4, which is just 1/2. So that's 0.5. So again, in summary, okay? In summary, we have this. Our slope or our equation is equal to y is equal to our y is equal to 0.4x minus 0.2. Our slope is equal to 0.4, and our x-intercept is equal to 0.5. Let's go to the other table. Another table wherein we took in consideration, okay, what did we take in consideration? We have time as a function of distance, because the crew does not stop in working. They don't rest, okay? The crew members don't rest, okay? They are just working, and they don't have any kind of timescape. There's no waste of time, so that we could take d as or t as a function of distance. Now this is the table. So that table, okay, has this graph, as you see, and what's particularly important here is the y-intercept. Okay, so you could notice our y-intercept appearing at 0 and 1. So at a distance of 0, there is an x or a y-intercept occurring somewhere at from the origin to a certain y unit. So let's compute for the function algebraically. So we have our points. We're still concerned with 2 points here. We have 0.2 and 1. I'm choosing the first and second again, and third again. Okay, and 1.0 and 3. And I will get this slope now. So what's my slope here? My slope would be y2 minus y1 over x2 minus x1. That's equal to 3 minus 1 all over 1.0 minus 0.2. So that would give us 2 over 0.8. And 2 over 0.8 is 2.5. What is my equations? I'm going to choose 1 and 3. So 1.0 and 3 to be plugged into my original, into a certain general equation of the line. Y is equal to mx plus b. So if my y is 3 and my m is 2.5 and my x is 1.0 plus b, I could solve my b now by transposing this value to the other side. So I have 3 minus 2.5. It's 2.5 times 1.0 is just 2.5 is equal to b. And so my b is equal to 0.5. Okay, now we're going to write the equation of the line for this inverse function. So we will have y is equal to, what is our slope? It's 2.5. So 2.5 x, we use x just to show a relation between inverses. 2.5x, and our b is positive 0.5. So we have plus 0.5. This is our graph or our equation for the linear function defined by t is equal to g of d. Let's make a table. So in summary, we have our y is equal to 2.5 plus 0.5. Our slope is equal to 2.5, and we have a y-intercept occurring at 0.2. How did we get this y-intercept? To get our y-intercept, let x is equal to 0. And we solve for our y. So if our x is equal to 0, then y is equal to 2.5 times 0 plus 0.5. So our y is equal to 0.5. This one should be 0.5. I think it's just a mistake on the typing mistake. So this one is not 0.2, it is 0.5. So our y-intercept is also important in showing you the this graph, because we're going to actually do it in reality, okay? That this inverse function, as on the other slide, okay? So those intercepts are important in delivering the a discussion on the next lecture, which is about invertibility and domains. So now we are still on the inverse of a function, and we're going to we actually defined it algebraically. So now we're going to present the summary. We have here our function f of x, okay, which is equal to 0.4x minus 0.2, and our inverse is equal to 2.5x plus 0.5, or that's also could be written as f negative 1 of x, and this is f of x, to show that they are inversely related. Now let's solve using algebra again how this thing of getting the f negative 1 of x using algebra work. So let our y is equal to 0.4x minus 0.2. To get our f of negative 1 of x, first we have to interchange our y and x. That's why now instead of y it becomes x, and instead of x this becomes y. And then we're going to plug in the remaining components of our expression. So x now is equal to 0.4y minus 0.2. And then we are to solve in terms of y again. So solving y in this case gives us x plus 0.2, which is equal to 0.4y. To get rid of the component, the literal or the numerical coefficient of our y, we need to divide both sides by 0.4. So divide both sides by 0.4 by 0.4. And so solving gives us y equals x over 0.4 plus 0.2 all over 0.4. So in this case, we will now get our equation, which is 2.5x. 1 over 0.4 is just 2.5. Plus, this is just 1/2 of each other, so 0.5. So as you can see, this coincides with what we get in here. So our f of -1 of x is just an inverse of our original function f of x, which is 0.4x minus 0.2. So this discussion ends our explanation for defining the inverse of a function by means of algebra.